Today what we want to do is we want to talk about functions, domain and range as you begin a new unit. So the first thing we're going to talk about is, I want to go ahead and talk about this word right here called a relation. Now, a relation, when we think about relations, you need two things going on, such as a relationship. In math, a relationship is defined as it's a set of ordered pairs. Now, with a set of ordered pairs have an x and a y. Now, this x and a y have some different names to them. This x is called the input. This y is called an output. Okay? Now, another name we use for the input is called the domain. And another word that we use for the output is called the range. Now, when we think about ordered pairs, we can think about x and y as inputs and outputs, domains and ranges. But we can also think about this. Think of x as independent. If I gave you a certain number for x, doesn't matter what number you pick, 7. The y value is dependent on the x value. And so another word for the range, the output, the y, is dependent. I'll give you an example of a relation and how it works. A relation might be this. If I gave you a letter, like an M, and I gave you this prompt, give me a state that begins with the letter M. Okay? Well, I'm going to put it as an ordered pair. M could be Missouri. M is your input. Missouri was their output. This is a relation. 2, 3 is a relation. It's an ordered pair. We can make all kinds of things into ordered pairs. Now, there's a specific kind of relation that we want to talk about here in just a moment. But sometimes what you'll see is you'll see what's known as a mapping. It's another M word, but it's not a state. So let's create a mapping. And what this is, it's a diagram that shows your input and your outputs. If we started with a letter M and said, okay, give me in this case a state that begins with M, we could draw an arrow and say, well, Missouri. That would work. But it's not the only one. We could say Maryland. We could also say Michigan. And you can run through the 50-state song in your head, and you can find a lot more of them as well. So, the specific kind of relation I want to talk to you about is the one we're going to deal with, and it happens to start with the letter F, and it's called what's known as a function. And a function is defined as this. It's a relation. It's a relation where each x or input has exactly one y or output. Function. Relation where each x or input has exactly one y or output. Now, if we take a look up here, this not a function. Because each x has more than one y. Now I'm going to give you a list of ordered pairs here, and we're going to see if this is a function. Let's take 2, 5, and 3, 6, and 4, 1, let's say. This is a function. Each x is paired with one y, and I'm going to map it to show you that. 2 goes with 5, 3 goes with 6, 4 goes with 1. Function. Yes. Okay. Let me show you something that's not a function. 2, 5, 3, 6, 2, 1. So if I make a mapping, I'm going to use the inputs, 2 and 3. Now if I list the outputs, I have, I have a 1, a 5, and a 6 if I put them in order. Now this 2 goes with the 5, and this other 2 goes with the 1, and that's a no-no. It's okay that 3 goes with 6. This is not a function, because 2 goes with both 1 and 5. Now, to finish that part off, let me show you this. Let's say we had 3, 5, and 4, 5, and 6, 5, let's say. Then we made a mapping. Well, with this mapping, we'd have 3, 4, and 6, and we have an output of 5. Now, it is okay, where each x has exactly one output. Yes, 3 goes with 5, and 4 goes with 5, and 6 goes with 5. This is a function. This is a function. Okay? That's the difference between them. So kind of take a look at the mappings that you see there. So if we expand on this concept just a little bit more, there's a test we can use. And you're going, another test. And the test we're going to use next is, how do we tell if something is a function or not? Well, the test we're going to use is we're going to use what is known as the vertical line test. And I'm going to draw a quick graph. Okay, just like so. Now what I'm going to do is I'm going to put a vertical line through this. Now, if I put any vertical line through this graph, notice each vertical line crosses the graph once and only once. This is a function by the vertical line test. Now, if you were to draw a graph such as this, and you ran a vertical line through it, would that vertical line cross that graph in more than one point? The answer is, it crosses it twice, not a function. Not a function. That's the difference between the two. So one more time, if we were to draw something like this, a vertical line would go through it. This is said to pass the vertical line test. Functions. So what is the notation we use for functions? Well, what we do is we give functions a name. And functions are like equations. Okay? So we might say f of x equals 3x minus 2. Now what does that really mean? Let me get rid of this parenthesis here. What does that mean? Well, it's f of x is kind of like y. Y equals 3x minus 2. Okay? Now I'm going to write another function. G of x equals x plus 5. Now, g of x is also the same as y. Okay, now, notice you can get really confused because we have something that's a y and something that's also a y. Well, which one are we talking about? That's why we use f and g and other letters. So, I'm going to get rid of these y things for now. Just understand f of x and g of x is y. Let's say we wanted to find the following. F of 4. Okay. So if we want to find f of 4, here's what we do. We find the f function. Aha! It's right over here. And this means that x is 4. So what we would do is every time we see an x, we put 4 in place of it. Okay? So we're going to have 3. There's an x, so 4 minus 2. From this up here, 3x minus 2. So then we solve it, order of operations. This is 12 minus 2, which is 10, so we would say f of 4 is equal to 10. And we're done. Let's do g of 4. Well, for g of 4, I have to use the g function, which is this one right here. And where I see an x, I'm going to put in 4 there. 4 plus 5, and g of 4 would be 9. And I've got it. That's what I'm trying to do with functions. We call this evaluate the function. Okay, so if I said evaluate f of -1, you would take f of x, which is 3x minus 2, and every time you see an x, you would put a -1, which gives us, what, -5 it looks like. Okay, so the last things I want to share with you regarding functions includes an application or two. So let's look at that right now. So here's what I want to look at with you. Let's say we have this function. And it is, let's do d of t. That's how we say it. D of t is equal to 50t. Okay, let's say this function represents, let's say this is speed in miles per hour. And t is time. And we want to evaluate d of 3. Well, how would we do that? Well, what this means is I want to know how far I went. We'll say d is distance, because distance equals rate times time. I would put 50, and I would put the 3 in for t, and I would get 150. That tells me how many miles I would go in 3 hours at a rate of 50. It's a function. Let's say I want to know how far I'd go in 7 hours. I would take 50 times 7 by putting 7 and 3 back in for t, and it gives me 350. That's an application of functions right there. Now, another application might be this. Let's say that, you know that shirts cost, let's say $15 each. And you want to buy a maximum of 5 shirts. Okay, and we want to know what the domain and the range would be. Well, the amount of money we're going to spend on shirts depends on how many we buy. So if we buy 0 shirts, we're going to spend $0. If I buy 1 shirt, I'm going to spend $15. If I buy 2 shirts, I'm going to spend $30. 3 shirts in the domain, $45. 4 shirts, $60. And 5 shirts, $75. Okay, so if I were to graph this, remember domain is X and range is Y. I have a bunch of ordered pairs. I would have 0, 0, because this 0 matches with that 0. And I just go down the line. 1, 15, 2, 30, 3, 45, 4, 60, and 5, 75. And what I would have is I would have a graph with, well, a bunch of dots like so. Okay? So that's the domain and the range. Now, if I said that, f of x is equal to x plus 7, and if I gave you a domain of 2 and 4, my range would be found by putting 2 and 4 in. So 2 plus 7 is 9, 4 plus 7 is 11. That's functions. That's an introduction to functions, guys and gals.